When we passed by Pluto last July, we saw this vast region we called the heart. Kind of looked, it was bright and heart-shaped, but really the interesting part was on the left side, the left ventricle, if you will, a vast plain of bright ice, which we called informally Sputnik Planum. And what we've learned since then is that plain of ice is actually mostly solid nitrogen ice, and it's also not even level with the rest of Pluto. It's a big depression, and we think it's basically it's nitrogen ice has filled up an impact crater, a big impact basin, actually, something created by a very large impact, probably 4 or more billion years ago. It's basically a sea of solid nitrogen. It filled up from all of the nitrogen that ultimately came out of the interior of Pluto as it formed and heated up. So it's basically the biggest reservoir of that kind of material. It's just because it's low. If the basin didn't exist, the nitrogen would be like in little pockets here and there, and it wouldn't be doing this sort of activity. We see this amazing pattern of welts or blisters or basically cells of bumps, slightly raised, but are tens of kilometers across and maybe only 100 meters or less high. Even the modest heat flow leaking out from Pluto's rock, from the decay of radioactive elements, is enough to drive this process. We think actually that the overall surface is replaced, completely replaced, every 500,000 years or so. So it's a vigorously, from a geological point of view, churning layer of solid nitrogen along with some